Hello everyone, welcome to our next talk from Tobias Miller and Ludwiko Denitz about USB-borne attacks.
Right, perfect. Hello. Maybe. Perfect. Hello. Is this on? Oh, perfect. Okay. So if there's trouble with the microphone, let me know. So I'm Toby. Hello. Don't know if you know me. I'm in the GNOME project, and so is Ludovico.
I'm Ludovico. Hi.
And I'm very happy to be here and to be talking to you about, well, the attack surface of USB. How many of you have a device that's capable of having a USB device attached? Quite a few. There's some who haven't raised their hand. I'm surprised. Like, do you have a computer? So we're working on protecting against rogue USB devices. That is, Ludovico is doing all the work, and I'm telling him how good he is, and I congratulate him to his achievements. And we will present what we think, or how we think we should introduce these capabilities of protecting against USB devices such that they actually work in terms of they unfold their protection capabilities. And what that means, well, you will hopefully see once we have the examples of why we think it doesn't right now. But first, let me tell you really quickly why I believe that GNOME is in a very good spot of providing these protection capabilities. So this whole reason of GNOME's existence, as you all know, because we're at FOSDEM, is freedom. So GNOME was created as a free alternative, to back in the day proprietary systems, and there's many definitions of freedom, including those, for your free computing. We also believe that you should be free from concerns of your computing being compromised, and we ought to achieve this, as well as possible without compromising on your way of using the machine or your usability. Why do I think that we're in a good position? Because it turns out that filtering out extraneous information is the basic function of consciousness. So your brain does nothing else but filtering out all the unnecessary stuff. And I think that with GNOME we found workflows and ways of interacting with the user that prevents, unnecessary things and allows the user to concentrate on what, they want to do. Because we firmly believe that the user does not sit in front of the computer because they like to sit in front of the computer. I'm sure many of us do. But most people, we believe in the GNOME project, are sitting in front of their computer because they need to perform a task. And if you interrupt them performing the task, then users go to great length of getting back to their work. So I believe that once you make the user part of your security system, you're going to have a bad time. You must not, make the user make decisions that they will regret. And in fact, there have been studies, academic studies, which show that, you better throw a coin rather than letting the user decide. You end up with better decisions. So what is the problem about interrupting the user? Well, as I've said, once you distract the user from what they want to achieve, they will want to go back to that. And they click on that button on the lower right because they know that this click makes this annoying dialog disappear. So prompts are dubious in first place. Security prompts are just wrong. I claim that you must not prompt the user or interrupt the user during their work with a security-relevant prompt asking the user something. Worse, if you're making this decision that the user took under stress, permanent, I claim that this is plain evil. You must not do that under any circumstances. If you take one thing away, then it's this: do not have interactive or user interaction in a way that distracts the user from whatever they're doing, and make this decision permanent such you prevent the user from learning how to undo this decision. So don't do this. What do I mean? So I've brought a few examples. It's GNOME projects, it's GNOME software, so it's I'm blaming and shaming, but it's all us anyway. It's this is you all know this. This connection is untrusted. Do you want to continue anyway? This happened when you opened your chat application. Imagine the user, they want to chat. They open the chat application, and they're being asked, "You've opened this chat application. Do you really want to open, or rather not? Have you decided that you within this 20 milliseconds that I've took to load this dialog, do you now not want to open the chat application?" And I sympathize with the developers of using this user interaction because it's a relatively cheap way of alerting the user and pushing off responsibility. But I can talk about this at great length, but we don't have time for that. So there's another one which I liked. your software or this software, this is a package install, like some software installation thingy. And it says, it tells you that the software you've just downloaded isn't signed and is not trusted by a provider and so on. And we can make sense out of that because we're in the security dev room, we're the experts in the field. But I have parents and they want to use the computer to send me an email, preferably encryptedly and so on. But this is gibberish. This doesn't make any sense. Like, how would they know whether, this software is trusted or not? Like, they don't have any clue. And this is my absolute favorite. It's, you get this prompt, and it says, Albert found a new update which fixes your problem. Please run before submitting the bug. pkcon update dash repo dash enable. And then, yes. What? Like, so it's terrible, right? And I think we can generalize this into if you have a security system and you require the user to do anything with it, that's fine, but be ready to lose half of the audience, half of your user base with every single click or keystroke. And because we're at FOSDEM, I thought it'd be funny to show you this. Does anybody remember or know what this is? Key signing. Yeah, what do these people do? Like what do they actually do? Yes, they do key signing, but what do they do?
They take IDs on the...
Yeah, they walk along each other and they mumble fingerprints like these hexadecimal numbers, and it takes ages and it's awful because it's cold because it's February, and like in the middle of Europe it's like cold. And then you get home and then you're not sure what you actually read and so on. So it's terrible. And well, it's we've also fixed that, I think. So there's GNOME key sign, but we're not here to talk about GNOME key sign. But that's the mindset, right? We're trying to reduce all these things that security people came up with by something that, well, will hopefully be able to be used by, normal people. So that's the general mindset of why I think, or we think, we're in a good position. And now I'm very excited to hear Ludovico talk about the actual USB stuff.
So, as Toby said, USB devices are everywhere, and the users, maybe most of the time, don't think that USB is a threat to their computer. And maybe even the most common scenario is when a user locks his computer, it goes to the bathroom, and it leaves the computer unattended. In this scenario, the USB ports are still running, so someone can pass by and plug a malicious USB device to the computer. And most of the time, users are not aware of this. And so USB devices can be really dangerous. For example, just the recent screenshot of the CV list for USB related to USB, it's has more than 200 entries. And the most famous attack to USB using USB device is the bad USB, where malicious device. It was just a pen drive, but it also advertised itself as a keyboard. So when you plug this device in, it can act as a keyboard and enter keystrokes automatically. So this is a CV that we tried to demo, and this is a VM of Ubuntu 14.04 because the CV is 2 years old. And just using a specially crafted USB device like this, it's an Arduino Leonardo clone. It advertises itself as a MIDI keyboard that has a bug in this particular kernel version, and just plugging this device in this computer, it will create a kernel panic. This can also be exploited to gain a root shell in this computer. So in this case, it's just a kernel panic, but it can be even worse.
From a MIDI keyboard. When's the last time you've attached a MIDI keyboard? So any USB device has the privilege of loading any kernel driver that you've installed on your system. Turns out that if you have a general purpose distribution, well, then you have all the drivers that have ever been written for Linux. ever. And it turns out that this is quite a large code base. Your attack surface is very large in this case.
Yeah, that's right. And what other people already did to mitigate this USB problem? Well, for example, in Windows, there is Kaspersky that let you enable USB protection, and every time you plug a new device, you'll get this prompt with a PIN that you need to enter with the newly plugged device. And it's a confirmation that you are willingly plugging a keyboard or a mouse in your computer. This is a USB guard. It's this is the UI of USB guard. It lists all the currently plugged in USB devices, and it says if they are allowed or blocked in the current state. And this is the related setting page of USB guard, where you can set the default action for new USB devices and the timeout, other stuff. In practice, when you plug a new device, you get this pop-up right here. It has a bunch of numbers and letters. It says the serial number, the name of the device. This is the USB class, and you have 23 seconds to decide if you want to allow it or block. And if you don't act in this 23 seconds, this pop-up will go away, and you have this USB device that will not work. This is USB Guard GNOME. It's a better attempt to managing USB protection. It still lists all the USB devices that you have. And when you plug a new device, you get a notification, better integrated in the system with the allow or block button. But still, in this case, the user needs to decide what to do. And also, if you don't press any of these two buttons in maybe 5-10 seconds, this notification will go away, and you will not be able to see these buttons anymore.
Slide.
Yeah.
You can select allow or block with the keyboard. If I plug in a USB device which
This
includes a keyboard driver which already does allow for you.
the new plug. The new plugged-in device is blocked until you press allow. So
if I plug in a keyboard runtime, I cannot allow it because the keyboard doesn't work.
if you don't have any other mouse or keyboards already connected, you cannot.
So malicious device already inside or connected to the computer when you turn it on is accepted.
If they are authorized at boot time, yes.
So for the internet, there have been many comments around whether this dialog now could be used from this malicious keyboard that you've just plugged in.
So
The answer is we get back to that in a few slides. So
the thing is that you can clone USB device. So if there is any rule that allows
Right.
some kind of USB device with a specific serial number, you just clone it and it is allowed by default. You don't see this pop-up and you can play with it.
Yeah, this is are just numbers advertised by the device itself, so you can clone them, and if you know that a particular device is already authorized, you can clone this the device with yours. So then we go here, where even just installing USB Guard with its UI, a bunch of users completely blocked their self from the,
it's very secure.
from the system. Yeah, in this case, they are completely protected from malicious USB devices. So our attempt here is we have a few takeaways here, and the first one is that we don't want to lock users out from their system, and we tried an approach where is that we incrementally build the protection So we started from a simple cases, and then we grew it up. For example, the first step was a switch on-off, where you can disable all new USB devices. This was related to a simple use case where the user maybe they want to go for a travel, and so they bring their laptop with them, and they want to be secure against USB devices that some user may plug in their laptop, so they just turn on the protection and no USB devices will be allowed. Then a more smarter protection, it's while lock screen is on. In this case, if the lock screen of your computer is on, then no USB devices will be allowed. If the lock screen is off, then you can plug new USB devices, and this is because if your lock screen is on, maybe it's because you are not in front of your computer, so you don't want to plug new devices. And the first step that is still a work in progress is to treat differently the keyboards, because they are one of the category more dangerous for USB, because you can plug a keyboard that automatically inputs some keystrokes on your belief. So this is how we present our functionality. This was a concept where in the GNOME Control Center, in the Privacy tab, we added this disallow new USB devices row, and it had a simple on-off switch. And
We're being hacked.
Someone disallowed USB devices.
The second attempt for the scenario, we had this drop-down menu with where you can select the protection level that you want. This is like always protect, or only when the lock screen is locked. And this is how it currently works. So it's okay, it works. We have this on-off switch, and then you can select the protection level that you want for your USB devices. And it also checked because we, in the backend, we use USB guard, so it checks if USB guard is currently available in your system, and if it's not, then you cannot turn on the protection. We also show an icon in the top bar, letting the user know that the USB protection is currently active. And also in this case, if USB guard is not available or the protection is not active, we don't show the icon. And this is a recap, I don't know if you can see this, of what happens when you plug a new device in your computer. If the USB protection is disabled, then the device will be authorized, or it will, for example, if you have USB guard installed and manually configured, or use a third-party UI for USB guard, then from the GNOME standpoint, we don't block this device. We let the user do what they configured in their system. If the USB protection is on, then we, as GNOME, are the one that manage the USB guard configuration. So if the protection is never blocked, then we manually authorize the devices, new devices that are plugged in the system. If you have a block with lock screen, then we check if the lock screen is active. If the lock screen is not active, then we authorize the device. If the lock screen is active, we added this extra check about keyboards, and we check if the plugged device is a keyboard, because if, for example, your main keyboard breaks and you have the protection enabled, then you are unable to plug new a new keyboard in your system, and you are basically locked out of your system. Yeah. So in this check, we control if the keyboard that you are trying to plug is the only available keyboard in your system. If it is, then we authorize the keyboard even if the protection was active. This is mainly a choice. We choose that because we are willing to compromise a bit of security in favor of a more usable system. Okay, this is the...
Right. So notice how we've tried very hard to not ask the user about whether they want to have this device attached. We try to infer the intent of the user by other means that we have available as the session, for example, the lock screen. And we hope that this provides better protection overall, knowing that users will know the security solution without maybe even knowing that it exists because it just works, And we haven't finished, this is all work in progress, right? So if you have comments or ideas, then now is the perfect moment because we're just right now in the process of, letting all bits and pieces fall in place so that this works. So if you have ideas as to, what else needs to be done or should be done, and we're all ears for taking comments regarding what to do. I think the most prominent attack that we've seen, this bad USB stuff, we're trying to be clever about this and try to swallow the keys that are not, or that we consider to be dangerous. So a keyboard, can press all sorts of keys, right? And we somehow need to deal with a keyboard pressing, say, Alt F2 and then R or something, because we wouldn't want a malicious keyboard to steal our Minesweeper high score or whatever. So we're in the progress of writing this code and getting the infrastructure in place to detect whether keystrokes have come from a keyboard that we are not fully trusting yet, maybe. And this is all being developed right now as we speak. So again, if you have comments around this, please approach us. And let me just finish up this last slide. We have other things that we have on the horizon. The most important one probably being the USB Type-C authentication. So there's in the standard is a way for USB devices to be authenticated. So in the future, USB devices will have private keys and certificates, and then you can ask the device whether it really is that device that you think it is, and for better or worse. I don't see how it currently would work in Linux, so we will have to deal with this situation eventually. And
it's broken by design.
Well, sort of. There's Thunderbolt as well. It's you could argue that it's very similar in what it does and how it works. So we might touch base with the Thunderbolt stuff and reuse things and bits and pieces from there. Another bigger problem is that if we wanted to eventually ramp up protection capabilities, as we've mentioned, we want to start slowly and then incrementally build up our protection capabilities. And one thing we don't know yet how to do properly is the early boot phase, before our stuff even runs. That's a bit, unknown how to do that. With that, I think we're ready to close and take questions. And first, we'd like to thank you for your attention, and then we're happy to discuss, now or later, of course. So there have been a few hands. Maybe.
Okay, so what do you...
maybe let's use the microphone for the internet.
So what do you authorize, devices or interfaces?
Right. So us using USB guard, there's only devices for now.
Okay, because kernel now supports also interface authorization, and I think it is way better,
right,
because the typical attack vector for that to still exploit the same CVE would be just to provide a man-in-the-middle device that will introduce with the same vendor ID, product ID, etc. as keyboard, and add interface with the MIDI.